a Hess's law problem, we need to try and reproduce this equation by combining these two equations here somehow. I'll start by focusing on something that appears in our target equation and only in one of the equations given, and that's CO2. We want 1 mole of CO2 in the products, and equation A has 1 mole of CO2 in the products, so that's a good place to start. Alright, so here's the equation rewritten, and we have the value of delta H inside the brackets, the original value of delta H inside the brackets, and we're going to multiply it by 1 because we haven't done anything to this equation. We use it in the direction it's given, and we haven't changed any of the coefficients. The next thing I want to focus on is the NO. NO appears in the reactant side here and on the product side in equation B, and it only appears in equation B. So in order to get to this target equation, we're going to have to reverse the direction of equation B, and we're also going to have to change the coefficients. Instead of generating, it generates 2 moles of NO2, so when we reduce it, reverse it, it will consume 2 moles of NO2. We only need 1, so we're going to multiply all of our coefficients by 1/2. So we reverse the equation, and we're going to multiply all the coefficients by 1/2. So we take our original value of delta H and multiply it by -1/2. Alright, we're going to combine these two reactions to see where we are with respect to the target equation. We see that we produce 1/2 mole of O2 in one reaction. It's consumed in the other, so it will cancel out and not appear in the net reaction. Alright, so we see when we add these two reactions, we are at the target equation. When we added these, those things that are on the reactant side stay on the reactant side, those on the product side stay on the product side. Now to find the delta H of the net reaction, we add these two quantities together. Alright, we have our final answer. Our value of delta H net is minus 373.8 kilojoules, and it's for this reaction as it is written.